You are listening to The Vocal Technologist. Spoken tech for your ears.
If you're tuning into The Vocal Technologist for Product Thursdays, you probably know the feeling. The pace of change in data architecture, it feels less like a stream and more like a fire hose.
Right. Aimed directly at your face.
Exactly. It's just so dense, and keeping up feels like a whole separate job.
It absolutely is. And that's really why we're here today. The goal isn't to add to the noise, but to kind of carve a clear path through it. We've been looking at the latest architectural shifts, the big efficiency wins, all of it.
To figure out what actually matters.
What matters, and more importantly, why it saves you or costs you real time and real money.
Okay, let's unpack that then. And let's start with efficiency, because I think the most expensive resource in the data world is probably the analyst's time.
Without doubt.
And we're seeing this massive shift toward AI-native analytics, which is having a huge impact.
Yeah, it's a fundamental workflow redesign. It's all about moving the analyst away from what we call context hunting.
Context hunting. I love that. So that's what? Searching through old Slack threads, digging up a JRA ticket, trying to remember which notebook had that one metric definition.
Precisely. All that friction. You look at a company like Fair, they adopted Cursor and basically moved their entire analytics workflow into one AI native IDE.
So it's all in one place.
All in one place. The AI generates the SQL, it searches the code base, it pulls context from everywhere, it knows the schema, it knows the definitions, all the stuff a human analyst used to have to piece together manually.
And the result was pretty staggering.
Whoa, yeah. Analysis time dropped from days to hours.
Days to hours. That's not a 10% gain. That's a whole different reality.
It's a paradigm shift.
Yeah.
The takeaway is that the environment itself has to be intelligent. That's the future.
Right. And this whole push for efficiency, it connects directly to another big pain point I keep hearing about, cluster fatigue.
Ah, yes. Cluster fatigue, the sheer exhaustion, and frankly, the staggering cost of constantly spinning up and managing these huge distributed compute clusters for every little job.
The overhead just kills you.
It kills your margins and your team's morale. And it's forcing this big strategic pivot, moving away from those heavy distributed workflows to something much leaner, using local or small-scale compute wherever you possibly can.
Okay, but hold on. Going from a petabyte scale cluster to local compute for a massive data set, that sounds a bit like magic. How does a tool like Polars or AVRO handle a terabyte of data without, just exploding?
That's the key innovation, right? These tools, built on Apache Arrow, are incredibly memory efficient. They use things like memory mapping and slow copy transfers. So instead of chopping up data across 100 nodes and managing all that chaos.
That orchestration.
Exactly. You're just maximizing the power of one really beefy machine. It simplifies everything.
So you cut the management headache, you get speed from local processing, and you couple that with good storage.
Correct. The modern workflow is often Polars for the heavy lifting locally, which then streams into Postgres or writes directly to something structured, like Apache Iceberg tables. You get the best of both worlds.
That pragmatism is a perfect setup for our next point. And this is where it gets really interesting, I think. The whole event streaming backbone. There could be a big market shakeup coming.
We are talking about the Kafka ecosystem. Yeah, there's an analysis out there suggesting the market, which has been dominated by Kafka and Confluent for so long, is, well, it's getting saturated. Growth is slowing.
And consolidation is coming. The prediction is pretty blunt, isn't it? That Apache Kafka itself is fine, it's durable tech, but a lot of the business models built around it might not make it.
It's a serious thing to consider. As a leader, you have to be analyzing your vendor risk. The prediction is that either the big cloud providers will just absorb these services, or only a few specialized firms will be left.
So you double down on open source Kafka, or you make really sure your vendor is solving a uniquely painful problem for you.
Exactly. And this whole discussion always brings up that debate you see online every 6 months or so.
Oh, I know this one. Just use Postgres instead of Kafka.
Right. And we really need to be clear about why that's often a harmful argument. It's a fundamental misunderstanding of the tools.
They solve different problems.
Completely different problems. Postgres manages state. It's your source of truth for the now. Kafka handles event streaming. It's a persistent log built for insane throughput, fault tolerance, and this huge connector ecosystem.
So if I try to make Postgres act like Kafka,
you're just building a mountain of complexity to solve a problem that wasn't designed for. You'll struggle with scale, with delivery guarantees. It's a mess. They're meant to work together, not replace each other.
That clarity is so important. Let's look at a couple of companies doing this at huge scale. Datadog, for instance, they outgrew their shared PostgreSQL database.
Right. They needed to replicate data with low latency, but without crushing their production database. So they used asynchronous change data capture CDC with Debezium and Kafka. But the really smart part is that they actively denormalized the data as it was streaming.
Okay, why is denormalizing it in the pipeline so important there?
Because they were building a platform for faceted search. The normalized relational structure that's great for transactions is absolutely terrible for search performance. By denormalizing it midstream, they were engineering the data specifically for its end use case before it even landed.
We're seeing a similar kind of evolution over at Fresha, but they were focused more on the data format itself, moving from JSON to AVRO.
Yeah, JSON is easy for humans, but it's expensive for machines to parse, and it doesn't enforce a schema. As their data volume just exploded, switching to AVRO, which is binary, it's compact, and it forces you to use a schema registry, was a no-brainer.
The schema registry automates all that validation.
It's a lifesaver when you're dealing with that kind of volume and change.
And speaking of efficiency at scale, you have to mention what Pinterest did. They unified their entire AI infrastructure onto a single platform, standardized on PyTorch, scaled with Ray.
And the results are just stunning. They got a 100x larger model capacity using GPUs for inference.
With no increase in cost or latency.
None. It's just confirmation that having fragmented ML platforms is a recipe for wasting time and money. Unification is the only way forward.
Which brings us perfectly to the big strategic takeaways. Let's tackle what you call the FAANG infrastructure myth.
Oh, this myth is so dangerous. Companies see what Google or Meta built over 20 years with thousands of engineers, and they think, we should copy that setup. That's a trap.
You don't have their problems, and you definitely don't have their budget.
Or their headcount.
So if we're not supposed to copy the setup, how do we get those same core benefits? You know, the abstraction, the automation.
You take a hybrid buy plus build approach. You get 90% of the way there, scalable ingestion, ML, self-service, by using best-in-class managed products. Then you just build the custom glue that holds it all together. And, critically, you treat every single data artifact like a product, with an owner, with an SLA.
That fits right into this idea of pragmatic orthodoxy we're seeing. Teams are choosing human efficiency over some hypothetical, future-proof, complex system.
Absolutely. The mantra is measured investment. You only materialize the proven hot paths. Because, as one insight put it perfectly, resources are cheap, your time is not.
That's the whole ballgame right there. Your engineering hours are the real constraint. And that focus on time is even pushing innovation way down the stack. We're now seeing things like Columnar's ADBC drivers replacing old protocols like ODBC and JDBC.
This is kind of the final frontier for speeding up data transfers. I mean, imagine the difference between shipping a box of solid gold bars versus melting that gold down, pouring it into thousands of tiny cups, and shipping each cup individually.
I follow. The old row-based protocols like ODBC, they're the tiny cups, processing everything row by row with all that costly serialization for every single record.
Exactly. It's so inefficient. Columnar transfer with ADBC just moves the whole block of pre-organized data at once. That one architectural change can cut query times by over 90% in some cases. It's just smarter design.
That's amazing. Okay, let's shift gears to the really big one, this rapid, almost existential architectural change being driven by AI agents.
This is happening so much faster than I think people realize. AI agents are becoming the primary execution engines. They're the ones orchestrating workflows, making the function calls, handling the CRU'd operations.
So what happens to the traditional backends? What's their job now?
Their role is retreating. They're becoming all about governance and permissions. Their job is to say yes or no to what the agent wants to do. They manage the boundary, not the execution logic. Gartner thinks 40% of enterprise apps will have autonomous agents by 2026.
40%, that's an explosion. But we have to ground that in the reality of today's AI ROI. We're seeing data that suggests companies are actually losing a lot of money on this.
It's a necessary dose of sobriety. The numbers suggest companies are losing over $200 billion a year. That's a negative 45% ROI deploying complex AI when simpler, battle-tested algorithms would work better.
200 billion is a staggering number. Give me a quick example. Where does a big fancy model fail where something simple wins?
Inventory management is a perfect one. Why train some massive expensive model to predict ordering needs when something like economic order quantity or Little's law, which are mathematically proven, give you a reliable, fast, and often optimal answer? A skilled programmer with those tools is way more effective than a lot of the vendor AI hype.
So the trick is knowing where the sophisticated AI actually adds value, like predictive autoscaling. I thought Grab's use case for Flink was brilliant.
It's a perfect application. Traditional autoscaling is reactive, right? It waits for a spike, then scales up. So you're always behind.
Wasting money or creating latency.
Exactly. Grab used time series forecasting to predict the Kafka workload and align the CPU resources before the spike ever happened.
And the outcome.
Over 35% in cloud cost savings, just by being proactive instead of reactive. It's a beautiful use of ML to solve a real expensive infrastructure problem.
And as we move into this agent-driven world with software hitting APIs thousands of times a minute, our whole model for security and governance has to change, right?
Totally. You can't just rate limit an agent like a human user. That's why you're seeing new things like Cloudflare's anonymous credentials come out. They provide a way to manage all that high-frequency agent traffic and prevent abuse without needing to know exactly which agent made every single request.
And finally, we just have to make sure these agents are all speaking the same language.
Yes, which is why DBT Lab's open sourcing metric flow is so important. It's a semantic layer. It's about standardizing the definitions of business metrics so that when an agent asks for revenue, it means the same thing everywhere. It provides that common authoritative language.
So if we pull this all together, the big currents are this immense pressure for efficiency, which is pushing us towards AI-native workflows and away from costly cluster management. We're seeing consolidation in the streaming market.
And this strategic mandate to build pragmatically, to focus on abstraction and treat human time as your most precious resource.
And all of that is happening just as this massive architectural shift is hitting, where autonomous AI agents are becoming the main execution layer, and our backends are shifting entirely to governance.
It's a perfect storm of change.
So if Gartner is right, and 40% of enterprise apps will have these agents by 2026, here's something to think about. What proven, old-school, non-AI algorithms, like your economic order quantity example, should organizations be building into these agents right now to make sure they're actually profitable and not just another layer of generative complexity?
Because the tools change, but business physics remains constant.
A perfect place to leave it. Thank you for walking through the data ecosystem with us. We'll catch you next time.
Spoken Tech for your ears.